Hello everyone, in this video you will learn the difference between dishwasher method and cylindrical shell method to find the volume bounded by a region that rotate about the x-axis or y-axis. Let's say you have a region bounded by parabola y equal to x square and x equal to y square. Let's sketch the graph. This is your y-axis. This is your x-axis. So when x is equal to 1, y is equal to 1. When x is equal to 0, y is equal to 0. So 0 and 1, 1. Y equal to x square. It's like this. X equal to y square is like this. The region bounded by these two graphs is this one. The objective is to find the volume generated by this region when this region is rotate about the x-axis like this, or rotate about the y-axis like this. Let's sketch the graph. This is the y-axis, x-axis. So the two graphs like this. 1, 1. So the region is this one. It rotates like this. When you rotate it, you will get something like this. So the volume that we are interested in is the volume of this one, generated by this one, the region. Not the inside, but this region. Rotate about the y-axis. Like this. This one is your y-axis. This is your x-axis. You have 1, 1, 0, 1. So one graph is like this, another graph is like this. So when you rotate about the y-axis, so you rotate like this. You will have, this is the center, you will have one circle like this, and this is your another function. This one, this region, rotate, you will get a volume. The volume generated by this region, not the inside, but this region. First, we look when the region is rotated about the x-axis. Two methods. One is this, or washer. Washer if you have a hole inside, this without the hole, and cylindrical shell. So we will compare these two methods to find the volume generated by the region bounded by these two graphs when it is rotated about the x-axis. You should get the same answer for these two methods. First, we sketch the graph. It rotates about the x-axis. This is your y-axis. This is your x-axis. You have 1, 1. You have one function, another function. One is x square, the other one is x equal to y square. For this washer, what you need to do is to draw a circle. It rotates about the x-axis, so the center is the x-axis. One circle touch the first graph, this one. You have another circle with the same center using the large function. It's like this. The area that we are interested in is the one between these two circles, not inside. So if we add the area of this region from 0 to 1, you will get the volume. For a circle, the formula is area of a circle is pi r square. So we need to find the radius of each of the circle. So the large area minus the small area. V, the volume, is equal to large area. So you have pi. You integrate, the circle is one circle, second circle, third circle, fourth circle, until many circle. So from 0 to 1, you're moving x direction because it rotates about the x-axis. So the large circle, this one is x equal to y square. X equal to y square. We need to integrate x because we are moving parallel to the x-axis. So it should be y equal to, from here you get set x. So this one, set x. You have a square minus, and from here, the small circle, this one is x square. So this one, x square dx. If you solve this, you will get 3/10 pi. Now we use cylindrical share method. You should get the same answer. So you have the y-axis, the same x-axis. You have the two function. One here, one here. Rotate about the x-axis. So everything should be rotate about the x-axis. So the center is here. The same. This one, washer, you have center and then circle. Center, circle. But then you don't add circle plus circle plus circle. But you add cylinder plus cylinder plus cylinder. So you have the circle. The cylinder is, you add the height. Now this is the cylinder. Many cylinder from here until 1. From 0 until 1. So for a cylinder, the area is 2 pi r h. The volume is 2 pi r h. V is equal 2 pi r and h. You have r and then h. 2 pi r h. You add one cylinder one by one, you moving up. One cylinder and then you add another cylinder and then you add another cylinder and then you add another cylinder. Here you have one big cylinder. It's not like this. Washer, you move one circle, you move to the right. Another circle, you move to the right. Another circle, you move to the right. But for the cylinder, one cylinder, you move up, add another cylinder. You move up, you add another cylinder. So this one parallel to the y-axis. You rotate x, but for shell, you move parallel to y. So it should be dy. X-axis, washer, dx. X-axis, shell, dy. Okay, now your R and H. So this one is okay, this one is y square, but this one is y equal to x square from here. So now x is third y. So this one is third y. The radius for the circle is this one. So you move from center, you go up. The length is, you moving up parallel to y, so the length is y. Multiply with the height. Height is from this function, third y, to the y-axis is third y. From this function, y square to the y-axis is y square. The one that you want is this one. So, the length is third y minus y square. If you solve this, you will get 3/10 pi. The same answer with this one, 3/10 pi. Now the problem is, you have this region, you want to rotate it about the y-axis. We will compare these two methods again, this washer and cylindrical shell. Let's draw the graph. You have the y-axis, x-axis, function is like this, 0 to 1, x equal to y square, y equal to x square. This washer method, you rotate about the y-axis, so this one is the center, one ring here, the smaller one, and then you have the larger one, another circle, two circle. So this one, two circle, you go up another 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 circle. It means that we move up parallel to the y-axis. So V is equal to pi, integration y equal to from 0 to 1, 0 to 1 dy. And then this circle, the radius of the big circle minus the radius of the small circle. Since this one is dy, this one should be in terms of y. Y equal to x square, so x equal to third y. This one, no problem, because you already have in terms of y, y square. So, large circle minus the small circle. This washer, y-axis, dy. Now, we want to use cylindrical shell method to find the volume when we rotate this region about the y-axis. This is your y-axis. This is your x-axis again. You have 1, 1, 0. X equal to y square, y equal to x square. Remember, rotate y, so the center is at y. You have one circle here, and then you need to make this to become a cylinder, you add the height. In the circle and then the height. Now it become a cylinder. So the height is the large circle minus the small circle. So this one you are moving to the right because you have one cylinder and then another cylinder you move become to the right, to the right, to the right. Means that you integrate against x. So v equal to 2 pi. The difference is 2. This one no 2. Integration. So x from 0 to 1, x from 0 to 1. Then dx. So this one is, the large one is this one. So x equal to y square, y equal to third x. This one already in terms of x. So third x minus x square. And the radius is, you read this one, x equal to 1, x equal to 0. So this one is x. So this is the radius x times the height, third x minus x square. Radius and the height. You should get the same answer if you use this method or cylindrical shell method. You should get the same answer. What you need to remember is, if you rotate about the y-axis, you use this or washer, integrate against y. Shell, y-axis, dx. This, x-axis, dx. Shell, x-axis, dy.